This is notes 13, page 7. We're going to look at this problem here. It looks nasty, but it's essentially the type of problem we've just been doing. It's a compound fraction, and we're going to do it just the same way we did the other problems. It's an important problem because you will see this in calculus as you start to learn about this thing called the derivative. So I am going to think of this as I need this answer, and I'm going to divide it by that answer. Well, there's not much I have to do in the big denominator, but I do need to add in this numerator. So the numerator needs a common denominator. And that's where people go crazy. Let me take a little space down here. Let me show you something that you cannot do. And I see it frequently. People just like, I don't like the looks of this. Let me just do this. I'll just add plus h and plus h here. And now the denominators look alike. No. What you have is you're adding plus 1. You add plus 1, you change the value. You cannot do that. You cannot add something top and bottom to a fraction and keep the value the same. You just change the value. You're not allowed to do that. So the common denominator basically is what it is. X plus 1 times h can't be factored, so we scoop that in parentheses. X plus 1 can't be factored, so we scoop that in parentheses. They are not the same factor, and you only see each factor once, so the LCD is just the product of the two. It's lovely, but that's what it is. Okay, now, because of space, I'm going to subtract this numerator off to the side. Okay, so here's the first fraction. Here's the factor it has. Here's the denominator I desire. Which factor is missing? The x plus 1. So I multiply that top and bottom by x plus 1. Okay. Here's the second fraction. It has the x plus 1 factor in the denominator. It's missing the x plus 1 plus h factor. Remember, we will add the numerator, so I need terms in the numerator, so I'm going to distribute the 2 over that LCD because it's gross. And I'm going to distribute the 2 here, 2x plus 2 plus 2h. And now, since they have a common denominator, I can add the numerators. That's all you do when you add fractions is you add the numerators, but you have to be careful. Remember, this is understood parentheses, so you need to distribute that negative. So this will wind up being 2x plus 2 minus 2x minus 2 minus 2h. Now I'm going to put the LCD back in. X plus 1 plus h times x plus 1. And because of the nature of this problem, if you've done this correctly, a lot of terms in the numerator will cancel. Notice the 2x's cancel, the 2's cancel, you're left with negative 2h over x plus 1 plus h times x plus 1. Now, remember, that's only half the problem. So that's what my numerator reduced to. So I'm putting it in where it belongs. This is the big fraction bar. Divided by h. So remember, to divide, you multiply by the reciprocal. If you need to, write the h over 1 to help you with that. So we take the reciprocal of what we were going to divide by. So dividing by h over 1 will become times 1 over h. And I'm going to write in this numerator. Oh, there we go. And I gotta write it in again here. Minus 2x. Oh, 2x. It's supposed to be 2h. Silly me. All right. X plus 1 plus h times x plus 1. Another common thing that will happen because of the nature of the problem, you should find an h factor that will cancel. And so this reduces to negative 2 over x plus 1 plus h times x plus 1. And if you let h go to 0, you just took your first derivative. So it's a little bit of algebra that you'll wind up seeing if you go all the way to calculus. All right. The next two problems, they are compare and contrast. I want you to pause the video, try them both, think about how they seem different than each other, and give them both a try. Because remember, you are trying to prepare for a test, so don't just watch me do it, which I've been doing a lot of, just doing things for you. So turn off the video, give them a try. I'm going to go ahead and go over these. One of the things I will be testing for, do you see the difference? Do you see that we have two terms in this denominator? But here, in the numerator and the denominators, we have all factors. When your numerators and denominators are already all factors, that's actually very easy. So I'm going to start with the easy one. And some of you might think, well, x to the negative second, that's a term. Well, remember, you can always think of that as 1 times something. So now it's a factor. Factors, you can flip top and bottom. So I'm going to leave the 1 on top. I'm going to leave the x squared where it is. The y to the negative second, when I take the reciprocal, comes up as y squared. The x to the negative second, when I take the reciprocal within this same term, comes down as x squared. This is nothing but y squared over x to the 4th. You are done. Okay, hope you see that. All right. That's the easy one. Over here, because these are terms, 1, you can't cancel the x to the negative seconds. Now you could certainly see that one as a factor, but you cannot see this one as a factor of the entire denominator. It's a term, so you can't cancel the x in negative seconds. And you can't flip them. Now, you technically could flip this one, and for these problems, there are many ways to approach them, but you can't flip this one because that's a term. So what I'm going to do is the way I've been talking about it. I'm going to take the x in the negative second and flip it, keep it right there in the numerator. Okay? And then I'm going to flip this one, 1 over x squared, and this one plus 1 over y squared. All right? Now I have what we've been practicing with, a compound fraction. Although this one's a little bit different. Usually we've had to add the numerator, but I noticed the numerator is already one term. It's the denominator that's not. So I need to add the denominator first before I can flip. I cannot, I mean, that would be the other common problem. And if you want, let me just show you this. You can write it this way. It matters not. This division symbol is this division symbol. But what you cannot do is say, oh, I'm going to flip this term individually and flip that term individually. That's how I flip the denominator. No. That would be equivalent to distributing a negative exponent to terms. I need to combine these till they're one term, then I can flip. So the LCD of the denominator, the only two factors that you see, and these are in factored form because I just can think of it that way. So the LCD is x squared, y squared. So the numerator here is going to hang around for a long time. Okay, the 1 over x squared, it has the x squared factor, it's missing the y squared. The 1 over y squared, it has the y squared factor in the denominator, it's missing the x squared, so I multiply top and bottom by x squared. So this is 1 over x squared divided by... Now, let's save a little bit of time. This is my common denominator, x squared, y squared. I'm ready to add the numerators. So this is y squared plus x squared. Those are unlike terms, y squared plus x squared all over x squared, y squared. Okay. Now I am ready to change the division to multiplying by the reciprocal, because now this is all one term. I can flip it. It's times x squared, y squared, and I've been teaching math too long. Y squared plus x squared, that annoys me. I'm going to change that to x squared plus y squared. All right. Any identical factors to cancel? Don't miss the easy ones. This x squared, if you think of it as times 1, it can be thought of as a factor. So you can cancel the x squareds. And you get y squared over x squared plus y squared. And stop. You cannot cancel these y squareds. I mean, you can do the trick of calling that y squared a factor, but you can't down here. This y squared is not a factor of the entire denominator. It's a term in the denominator. So that's why you cannot reduce this anymore.